Hi there, it's time to get up to scratch. Today, we're going to look at the New Zealand curriculum for computational thinking, Progress Outcome 4. This video is for students who want to show that they have achieved this outcome, or for teachers who want to know more about how to assess their students. Let's begin. Progress Outcome 4 says, in authentic context and taking account of end users, students decompose problems to create simple algorithms using the three building blocks of programming: sequence, selection, and iteration. They implement these algorithms by creating programs that use inputs, outputs, sequence, basic selection using comparative operators, and iteration. They debug simple algorithms and programs by identifying when things go wrong with their instructions and correcting them, and they are able to explain why things went wrong and how they fix them. Students understand that digital devices represent data with binary digits and have ways of detecting errors in data storage and transmission. They evaluate the efficiency of algorithms, recognizing that computers need to search and sort large amounts of data. They also evaluate user interfaces in relation to their efficiency and usability. That's quite a lot more than the previous progress outcomes, so let's deconstruct this a little bit. The first phrase I want to point out is the using inputs, outputs, sequence, basic selection using comparative operators, and iteration. Now, we've talked about inputs, outputs, sequence, and iteration in previous videos in the progress outcome 2 and progress outcome 3 videos. So the new part here is the basic selection using comparative operators. Now, what this means in terms of a computer program is that the computer program is selecting which path or which sequence to take. So there's kind of a fork in the road. So a decision has to be made. So these comparative operators, which are a lot of the green blocks, they will show you how to compare maybe a number or an input or something that the program has generated from the user's input and make a decision based on that about what the output is or what calculation is done. The other main change here too is that with the debugging, it's not just about noticing what went wrong and fixing it. It's about explaining why things went wrong. So often in my videos, if you see me make a mistake, you'll see me kind of ponder for a while about what I did wrong and why and how that is affecting the outcome that's happening. I also, before we go on to any of the examples, want to talk a little bit about that last page, how the students understanding the digital devices representing data with binary digits and so on. Now, this is stuff that we're not going to really cover in this video. Maybe later I'll have a chance to make some explanation of these things. But the important bit to get out of this is the evaluation of the efficiency of algorithms essentially means that we want the computer program to get the result in the quickest possible way. Often you'll find, I don't know if you have the same experience as me, but when I'm running too many things on my computer, it overheats. And that's because too many things are going on in the computer and electrons are flying every which way, and that's heating everything up. So that's why the fan goes on. So we want to avoid computer programs getting bogged down in too many things, because even though they're really, really fast, sometimes, and some things like infinite loops, they can cause our computer to crash and then they don't work very well. And the last bit as well about the interfaces is we want the people using it to actually have a good experience, and you could probably do whole courses on that. But for now, I'm just going to leave it at looking at the inputs, outputs, and mostly the selection in this video. So for progress outcome 4, you're going to be using another set of blocks to show that you know what you're doing. Again, for most programs, will probably involve some sort of combination of motion, looks, and or sound blocks. And we've now been introduced to all the event blocks. And now we're going to actually look at all of the control blocks. So some of these should be new. Some of these are quite hard to understand at first. But if you check out our video on control blocks, you can have an idea of that. We're going to be using now all of the sensing blocks. And we're going to be looking at some of these operator blocks. We're probably going to avoid these and or not blocks because those are not the comparative operators. They're logical operators, and that comes into play in progress outcome 5, but the rest of the green blocks now can come into play. So let's go and move on to some examples. So this program I've made has two selection criteria. So I've created two sprites. So I've got my cat sprite here. And what it's going to do is, it's first, when I press the flag, it's going to forever continue, like repeatedly glide to 1 second to a random position. So it'll move around oddly, and it's going to keep on checking to see if it is touching the ball. So that's the other sprite here. And if it does touch the ball, it will say out for 2 seconds. Now, if I look at the ball, it's going to start off in the middle. And if it is touching the sprite 1, so if it's touching the cat, then it's going to go to it's the next costume, so it should change colors. It should go to a random position, and then it will wait 1 second. Let's see what that looks like. So you see the cat saying out, and then we're at a different color. Sometimes the cat's not going to touch it, but it's just to kind of showcase how this works and selecting the path that we go on. Stop it. This program is going to forever check if the loudness is greater than 10, which is quite low. And then it is going to play this recording that I made saying it is too loud in the classroom. If it is not too loud in the classroom, and let's just change that number so we can not get interrupted, it will continue to say good work, class. But if I talk a little bit louder, it's too loud in the classroom, be quiet. It's too loud in the classroom, be quiet. Told to be quiet. So this is another way to use that selection with the comparative operators this time. So we're using that green comparative operator to check if the loudness, which is the sensing coming in from the microphone on my laptop, if that is louder than 50. So in this example, I'm using a few different selection tools. So the first block of code here I've had when it sets up the dog to go to a certain spot, and it resets the timer. And now the selection here is that it's going to wait until the timer gets up over 10 seconds. And then at 10 seconds, it's going to broadcast this message 1. Now, if I look down here, message 1 will have the dog say it's too slow for 1 second, and then it will go right back to the beginning. So to actually play this little mini game that I made, this little block is important. So when the flag is clicked forever, we're going to be checking. So it's another selection point. If the space key is pressed, and then if it is, the dog is going to move 3 steps and go to the next costume. So let's have a look at that. I'm just going to turn off the timer so we can't see it. And let's see if I can actually get the dog to the end before. Hopefully now you have a better understanding of what is required for progress outcome 4. Note, though, that at this level, these examples probably wouldn't be sufficient on their own. You'd want bigger programs rather than just little tiny mini games that I've made here. Also, have a think, if you are at this point, you might want to consider trying to learn a few different computer languages, so possibly JavaScript or Python. But at progress outcome 4, Scratch is good enough to show that you know these things. And the final point on that is that remember that these bits of Scratch are only showing about half of what's needed. So there's a lot of other theory that needs to go with progress outcome 4. But hopefully you are prepared for this half at least. Until next time, happy programming. Don't forget, like, comment, and subscribe. Thanks for watching.